Centroid and center of gravity. Here is a rectangle of width b and height d. On its axis of symmetry, its geometrical center is. This is centroid. I have used letter C for centroid. Centroid is center of a shape. And what is this shape? A rectangle. Geometrical center of a shape is a centroid. Remember, there is nothing like center of gravity of a rectangle. It should be centroid of rectangle. Now you will understand it better. Here is a rectangular plate made of steel. So this is actual physical body. So it has a shape and it has mass also. So B is its width and let D be its height. Now it has rectangular shape. So on its axis of symmetry, it is centroid. Centroid is the center of shape of the plate, and shape of the plate is a rectangle. So centroid is the center of its shape. But this is a body, physical body. It has a mass also. And therefore there is a gravitational force acting on the body. The point where gravitational force acting on a body is assumed to be acting, that is called the center of gravity. And in this case, the same point is center of gravity. One more example. Here it is a rectangular plate made of steel and wood. So upper half is made of wood, lower half is made of steel. Now this plate is a non-homogeneous plate, now you can see. It has a rectangular shape of width, base and D is a depth. So geometrical center of its shape, that is its centroid. So here is centroid. But now you know that density of steel is more than wood. So lower half has more weight as compared to the upper half. And here center of a weight, that is center of gravity, has shifted on lower side. So now you will understand very clearly that centroid and center of gravity are two different concepts. Centroid is center of a shape and center of gravity is the point where mass of body is assumed to be concentrated, or where weight of the body, that is gravitational force acting on the body, is assumed to be acting. In case of homogeneous bodies, centroid and center of gravity coincide. In case of non-homogeneous bodies, centroid and center of gravity may not coincide. So remember all these points. Centroid is geometrical center of a shape. Center of mass is the point where mass of a body is assumed to be concentrated. And center of gravity is the point where the gravitational force acting on a body is assumed to be acting. In case of homogeneous bodies, centroid and center of gravity coincide. In case of non-homogeneous bodies, the centroid and center of gravity may not coincide. And the bodies we observe in our day-to-day life, we assume center of mass and center of gravity as the same point. In this video, we are going to consider only plane shapes. Now here is a plane shape. It is combination of standard shapes. There is a semicircle, there is a rectangle and there is a triangle. Now if you are asked to find area of this shape, then you can easily find out this area, provided you know formulae for areas of these three shapes. If you know how to find our formula for area of semicircle, formula for area of rectangle and formula for area of triangle, then you will able to find total area. It's simply area of semicircle plus area of rectangle plus area of triangle. It is actually primary secondary school level problem. Similarly, now in this video, if the given shape is combination of standard shapes, then how to find centroid we are going to study. And to find a centroid of such a composite shape, you must know location of centroid of standard shapes. That is location of centroid of semicircle, location of centroid of rectangle and location of centroid of triangle. If you know positions of centers of these three shapes, you will able to find a centroid of this entire shape. So let's have that information. Centroids of standard shapes. So here is a rectangle of base B and height D. Centroid of a symmetrical shape lies on its axis of symmetry, and a rectangle has two axes of symmetry. So here that centroid is. So it's a distance from edges of the rectangle. From horizontal edge, it is half of height of the rectangle, and from vertical edge, it is half of the base of the rectangle. This is position of centroid with respect to boundaries of the rectangle. Right angled triangle is a standard shape. So here is a right angled triangle of base B and height D. So centroid of right angled triangle is somewhere here. No, not somewhere here. You know exactly where it is. From its vertical edge and from its horizontal edge, you know its distances. So from horizontal edge of 1/3 of its height, and from vertical edge of 1/3 of its base. A symmetrical triangle, so it can be isosceles triangle or equilateral triangle. So here I have shown a symmetrical triangle of base B and height D. Height is measured along its axis of symmetry. Remember, height of an isosceles triangle is measured along its axis of symmetry, and the edge of the triangle, which is perpendicular to axis of symmetry, that is considered as a base. Now centroid of an isosceles triangle lies on its axis of symmetry. Axis of symmetry of an isosceles triangle is perpendicular bisector of its base, and that is why this distance is b by 2. On axis of symmetry, centroid lies at a distance 1/3 of its height. Properly remember the position. Centroid of an isosceles triangle lies on its axis of symmetry at distance 1/3 of height from its base. You will understand it better. Remember, height is measured along its axis of symmetry, and the side which is perpendicular to axis of symmetry, that is a base. So centroid lies on its axis of symmetry at distance 1/3 of its height. So 1/3 of D. So this is how we can locate centroid of an isosceles triangle on its axis of symmetry at distance 1/3 of length of axis of symmetry. That is called length of axis of symmetry, that is height of the triangle. Circle is considered as standard shape. Here circle is of radius r, but whatever. Centroid is a geometrical center of a shape. So of course, center of the circle is nothing but centroid of the circle. Quarter circle is considered as a standard shape. Now this quarter circular area has two straight edges which are perpendicular to each other. Let r be the radius of quarter circular area. So centroid lies at a distance 4r by 3 pi from its straight edges. Semicircle is a standard shape. Let r be the radius of the semicircle. Centroid lies on its axis of symmetry at distance 4r by 3 pi from its straight edge. How will you find area of semicircle? Area of circle is pi r squared. Simply divide it by 2. Semicircle. Pi r squared by 2. Okay, here is again a semicircle. Centroid lies on its axis of symmetry. If r is a radius of the semicircle, then centroid lies at a distance 4r by 3 pi from straight edge of the semicircle. Remember now, centroid of a semicircular area lies on its axis of symmetry at distance 4r by 3 pi from its straight edge. Now here is a circle of radius r, but we are not interested in the circular shape. Watch here. Now this colored area, it is a sector of a circle. How to find area of sector? So two things you must know: radius and semi-angle of sector. A sector is a symmetrical shape. The line, in this case this vertical line, the line which bisects angle of sector, that is axis of symmetry of the sector. So in this diagram, angle of sector is 2 alpha, and alpha shown in the diagram is a semi-angle of sector. So what you should know for a sector, r and alpha. What is r? Radius. And what is alpha? Semi-angle of the sector. What is the area of sector? So it is alpha r squared. Check, this formula is very much similar to area of circle formula. What is area of circle formula? Pi r squared. Pi is half of the angle of whole circle. Similarly here, Alpha is half of the angle of sector, that is we say semi-angle of sector. Now in this formula, alpha value is to be used in radians, remember. So be careful about this. Now location of centroid. In case of a sector, line bisecting angle of sector is axis of symmetry. So on its axis of symmetry, here I have shown centroid on axis of symmetry. So distance from center of corresponding circle, try to understand, this sector is portion of a circle. So here is a center of that circle. So from that center of corresponding circle, centroid on its axis of symmetry lies at a distance 2r sin alpha by 3 alpha. So remember this formula, 2r sin alpha by 3 alpha. Here is one more example for sector only. Watch, this colored portion is a sector. Centroid lies on its axis of symmetry at distance 2r sin alpha by 3 alpha. Now if I ask you position of centroid of a sector, your answer must be on axis of symmetry of the sector at distance 2r sin alpha by 3 alpha from center of corresponding circle. In calculations, remember, because we keep our calculators on degrees mode, numerator use alpha in degrees and at denominator you use value of alpha in radians. Now here is an example. What we are studying in this video, how to find a centroid of a composite shape, a shape which is combination of standard shapes. To find a centroid of this colored portion, shaded portion, divide this area into standard shapes. So how many standard shapes you can see here? If you think there is a hole or slot in that particular shape, then in your imagination fill that slot. So watch here, here this semicircular area we have imagined filled, and now the shape you get, you divide it in standard shapes. So it is a rectangle plus triangle. If you add area of rectangle and area of triangle, is it the given shape? No. From this shape you will have to remove semicircular shape. So semicircular area is removed area. So area of rectangle plus area of triangle minus area of this semicircle, and you will get the shaded area. So first step is to identify standard shape. So origin is given. To find a centroid means to find position of centroid, which is described using coordinates. So find centroid means find coordinates of the centroid. Now here origin is mentioned. So horizontal line through origin is x-axis, vertical line through origin is y-axis. It's very important to label origin x-axis and y-axis. And now draw neat, proportionate, bigger sketch, the given shape. But draw this shape, now I'll say shape by shape. So the three shapes you have identified, draw these three shapes one by one. So rectangle, immediately insert size of the rectangle and label this area, area A1. Always consider first areas to be added, that is proper way. So area A1 is rectangle. Then area A2, height 90, which we have mentioned here, and base 60. Remember, when you draw an area, immediately label it and insert the dimensions, all necessary dimensions. If it is rectangle, base and height, horizontal edge, vertical edge. If it is triangle, base and height. And label the area as A2. And one more area which is removed area, that is semicircular area. When you draw a semicircle, always draw its axis of symmetry. Always word I have used. Always draw its axis of symmetry and insert radius along its straight edges. Insert radius along its straight edge. Watch here in the given dimensions. Watch here in the given diagram, radius is inserted using an inclined arrow. But to solve problems, it is always better to insert a radius along its straight edges. Remember, horizontal distance from y-axis is x coordinate, vertical distance from x-axis is y coordinate. So xy coordinates are horizontal vertical distances. And this is area A3. So label the areas. This is first step. Divide area into standard shapes, label the areas, and be sure that you have inserted required dimensions of each area. For rectangle, base and height; for triangle, base and height; and for semicircle, radius along its straight edges. I am not just saying radius, I am saying radius along its straight edges. Now, these are standard shapes, and you know location of centers of standard shapes. So, we will locate center of each and every area in the diagram in order. So, C1, focus is on rectangle. So, somewhere here its center is, not somewhere here, we know where exactly it is, half of its base and half of its height. So, 90 is height, so half of height 45, and base of a rectangle is 60, so half of its base 30. And these dimensions you already know. Location of center of a rectangle you know already. So, just in this problem numerical values are there. Okay. Now, here it is a right angle triangle. Its centroid is somewhere here, not somewhere here. You know where exactly it is. From its straight edges at distance h by 3, b by 3. So, C2 is center of A2, height is 90, so 1/3 of 90, that is 30, and base is 60, so 1/3 of 60, that is 20. Remember once again, these are not coordinates of C2. These are distances of C2 from edges of the triangle. These are not coordinates, but these dimensions are going to help you to find coordinates of C2. So, first of all, knowing formulae for location of centroid, knowing position of centroids of standard shapes, locate centroid of each and every standard shape. So, one more shape involved here is semicircle. What do you know about centroid of semicircle? It lies on its axis of symmetry at distance 4r by 3 pi from its straight edges. So, on axis of symmetry C3, and where exactly it is? At distance 4r by 3 pi. I have labeled it as A, and numerical value of A will calculate now. A is 4r by 3 pi. Now put the values. What is the r? Radius of semicircle 30. Put it. So 4 into 30 divided by 3 pi, and you have found out area. And you have found out numerical value of A. And what is that A? Distance of C3 from straight edge of the semicircle. So this is how, knowing standard formulae, we have located centers of all the areas. So this is first step. What is that first step? Remember, draw the given diagram, construct diagram shape by shape. That is, one by one you draw the shapes. But when you draw shape, immediately insert necessary dimensions for those shapes. It's better to avoid inserting unit in the diagram, instead write dimension here outside the diagram, so that diagram will be very clean and it will help you to study geometry of the diagram. Now make a table. So watch carefully here, there are 4 columns. Which are the 4 columns? Listen. Shape, area of that shape, and xy coordinates of centroid of that shape. And now put the values one by one. Watch here. First shape, area A1, that is the rectangle. So draw a smaller diagram of that shape, smaller and similar. Check how that rectangle appears in the diagram. What is orientation of the rectangle? In the same orientation you draw the rectangle. So this is area A1. And of course it is a rectangular area, and from school level you are finding area of a rectangle 60 into 90. So put that value here. Second area A2, base into height by 2, 60 into 90 by 2. Calculate it on calculator and insert that value. Third area is semicircular area. Semicircle, area of circle is pi r squared. Semicircular area is a pi into 30 squared divided by 2, pi r squared by 2. 450 pi, but I have used a negative value. Semicircular area is removed area. So remember, here many students make mistake in the sense they simply forget that negative sign. Remember, if there is a hole or slot, that portion is removed portion. So you should use a negative sign for corresponding area. and you get the total area, that is the given shaded, that colored area, and this is the area. So you will not face any difficulty in putting values of areas in this column. Now we'll write x and y coordinates. Let's first write x coordinates of all centers. All three centers are in first quadrant. Check here, x axis and y axis. So all three centers are in first quadrant. So all coordinates are positive, of course. But you must know, and you know it, I know, that is horizontal distance from y-axis is x coordinate, and if it is on the right side of y-axis, positive x coordinate, and if it is on the left side of y-axis, it is negative x. Similarly, above x-axis y coordinate positive, below x-axis y coordinate negative. So take care of that. Now horizontal distance of C1 from y-axis, that is x coordinate. X coordinate is horizontal distance from y-axis. That means you must know where is y-axis. So when you write x coordinates of all centers, first of all be sure about y-axis, and then from y-axis one by one check distances of centers and put in this column. So C1, what is horizontal distance of C1 from y-axis? It is 30 millimeters, and it is on the right side of y-axis, so positive 30. X coordinate of C2 is not 20. Focus on all horizontal dimensions from y-axis up to C2. So horizontal distance of C2, watch here, it is a 60 plus 20. Check, it is 60 plus 20. So 60 plus 20, that is a 80. So put it here. And horizontal distance of C3 from y-axis. Now you know where is y-axis. So horizontal distance of C3 from y-axis, that is this distance. And it is 30. So put it here. But it is not just distance, it is x coordinate. On the right side of y-axis, x coordinate is positive. Now let's write y coordinates. Vertical distance from x axis, that is y coordinate. Check which horizontal line is x axis and then start writing y coordinates. So vertical distance of C1 from x axis. Vertical distance of C1 from x axis, that is y coordinate of C1, and it is 45, and above x axis means positive 45. Vertical distance of C2 from x axis, and how much is that? 30 millimeters. So y coordinate is 30. Above x axis means it is positive y coordinate. And vertical distance of C3 from x axis, that is y coordinate. And what is y coordinate of C3? A. A means 12.73 millimeters. So this is how we have inserted x and y coordinates of all these three centers in the table. And now use this formula. X bar is equal to summation ai xi divided by summation ai. So A1, that is area A1 into x1, A2 into x2, A3 into x3, and so on. Just put the values now. X bar is equal to, let's write numerator first, A1 into x1 5400 into 30 plus A2 into x2 2700 into 80 plus, but third area is negative, so minus 450 pi into 30, A3 into x3, and denominator total area, that is what we have already found out, 6686.28, and this is how you have found out x bar. Okay, let's find y bar. Y bar is summation ai y divided by summation ai. Therefore y bar is equal to A1 5400, y1 45, A2 2700 into 30, A3 is minus 450 pi into 12.73. So A1 x1 plus A2 x2 plus A3 x3, and A3 is minus 450 pi. That's why this negative sign here. Divided by total area 6686.28, and get the answer. Y bar is 45.76. And this is how we find. Find centroid means find xy coordinates of the centroid. So x bar is x coordinate of the centroid and y bar is y coordinate of the centroid. Don't forget to insert a unit. Now this is second example. As I have told you earlier, if you think that there is removed area, for example, or a slot, this quarter circular area, in your imagination fill it and then identify standard shapes. So here is a semicircle, a rectangle and a right angle triangle. So sum of these three areas, that is this area in front of you now. But one more area is involved, and that is removed area. Remove the quarter circle. So there are four areas involved. So first thing is we have identified four areas, and now simply follow the procedure. First of all, draw XY axis and origin. Construct this area shape by shape. One by one draw these shapes and immediately insert dimensions properly. So rectangle, so base and height. So I have inserted base and height. I have labeled it as area A1. Immediately label it as area A1. Then right angle triangle. What information is required? Base and height. Horizontal, vertical edges. So 150. Watch here, 60 plus 90. Diameter of the semicircle is twice radius, that is 150. So this vertical edge of the semicircle is 150 millimeters. That is nothing but diameter of the semicircle. Minus 90. So 150 minus 90, that is 60. That is height. So remember, when you have drawn this area A2 here, immediately check all given dimensions and insert the required dimension. So if it is a right angle triangle, length of its perpendicular edges. Now third area is semicircle. Always draw axis of symmetry of the semicircle. Don't forget, always. And insert radius along straight edges. Parallel to straight edges, you should insert the radius. Develop habit of inserting radius along straight edge. If it is a quarter circular area, in that case also insert radius along straight edges. And this is area A3. I have labeled it here. This distance is 15. 90 minus 75. Okay. Now removed area A4. What is the radius of removed area? 60. Check here. Again here I have inserted radius of this quarter circle along its straight edges, 60 and 60. Now locate center of each standard shape. Focus on the rectangle. Center of rectangle is somewhere here and not somewhere here. We know exactly where it is. Half of base and half of height. Dimensions are in millimeter. So 30 and 45. I have inserted. From vertical edge, horizontal distance is half of base. From horizontal edge, vertical distance is 45. Right now, don't worry about XY axis. Just locate center of each standard shape from its boundaries. And you know location of centers of the standard shapes. Area A2 is right angle triangle, H by 3, B by 3. 1/3 of 150, 50. And 1/3 of 60, that is 20. If there is no enough space inside the diagram to insert the dimension, then you may use this leading arrow. It will keep your diagram very clean so that when you put values of XY coordinates in the table or while studying geometry of the diagram, you will not get confused. Okay, third area is A3. What do you know about centroid of semicircle? So it lies on its axis of symmetry at distance 4r by 3 pi from its straight edge. I have labeled that distance 4r by 3 pi as A, and A can be calculated as 4r by 3 pi. Okay, and fourth area C4, its centroid is C4. It is quarter circular area. So from straight edges, location of centroid of quarter circular area, from its straight edges 4r by 3 pi. So I have labeled that distance 4r by 3 pi as B. So we'll calculate A and B. So A is 4r by 3 pi, 4 into 75 by 3 pi, that is equal to 31.83. Similarly, use the same formula but use value of radius as 60 and you will get B as 4r by 3 pi, 25.46 millimeters. So very simple calculations. Nothing difficult here because this is all you know. You know formula for area of standard shapes. You know now location of centroid of standard shapes. So construct a table. Now here there are 4 areas involved. So shape, area in millimeter squared, take care of unit, x coordinate in millimeter and y coordinate in millimeter. Now let's put the values. First area is a rectangle 90 by 90 into 60. So 5400. Second area is right angle triangle. Remember, you should draw similar right angle triangle. Don't just draw a right angle triangle. Draw similar right angle triangle in the same orientation. Check how right angle triangle is placed in this combination. And similar and in the same orientation you draw that shape here in the table. A very small diagram is enough here. And that is 150 into 60 by 2. Base into height by 2. Then third area is semicircular area, pi r squared by 2. Radius is 75. So pi into 75 squared by 2. And fourth area is removed area. Remember, fourth area is removed quarter circular area. Removed quarter circular area. Don't forget negative sign. But otherwise area you can find out easily. It is 1/4 of complete circle. So pi r squared divided by 4. Radius is 60. So pi into 60 squared divided by 4. And it is minus 900 pi. Don't forget this negative sign. It's very important. And now add these areas and what you get? The total area. Last problem, all centers were in first quadrant. So all coordinates were positive. But in this case, centers are in different quadrants, so be very careful. But of course, it's not at all difficult to write coordinates, just be very careful. Horizontal distance from y-axis, x coordinate. So first check where is y-axis. And have you noticed all centers are on the left side of y-axis? What does that mean? All x coordinates are negative. But one by one we'll write x coordinates. C1, horizontal distance of C1 from y-axis, it is 30, but negative 30 because it is on the left side of y-axis. Then where is C2? Be sure, in order, horizontal distance of C2 from y-axis. So remember here, many students make mistake, its x coordinate of C2 is not 50. That is why I am repeating this instruction again and again. Check where y-axis is. And horizontal distance from y-axis, that is x coordinate. So what is x coordinate of C2? Check here. 60 minus 50, that is 10. And since it is on the left side of y-axis, it is minus 10. Now horizontal distance of C3 from y-axis. Check again, x coordinate of C3 is not A. It is horizontal distance from y-axis. So check where is y-axis, and from y-axis up to C3, check the horizontal distances. So how much is that? 60 plus A, and A is 31.83. So 60 plus A, that is 60 plus 31.83, 91.83, and it is on the left side of y-axis, so negative x coordinate. And C4, horizontal distance from y-axis. So check where y-axis is. It is minus B, that is minus 25.46. So we have inserted all x coordinates. Now y coordinates of all centers. Y coordinate is vertical distance from x axis. Don't just say y coordinate vertical distance. Coordinate is a vector quantity. Vertical distance from horizontal x axis or vertical distance from origin, that is y coordinate. So check here where is x axis, and one by one consider vertical distances of centers. Above x axis y coordinate positive, below x axis y coordinate negative. So check here, vertical distance of C1 from x axis, that is 45, and it is above x axis, so positive 45. Vertical distance of C2 from x axis, so from x axis vertical distance of C2, check here, it is below x axis, and how much is that distance? 20. So it is minus 20. Vertical distance of C3 from x-axis. Check here, this distance. Vertical distance of C3 from x-axis. And how much is that? 15. 90 minus 75, 15. And it is above x-axis, so positive 15. And vertical distance of C4 from x-axis. Watch here. Vertical distance of C4 from x-axis. How much is that? It is a 90 minus B. Up to top edge of the rectangle from x-axis it is 90. 90 minus B. That is that remaining distance, length of this blue colored arrow. How much is that? 90 minus B. B is 25.46. So 90 minus B is 64.54. That is the distance of C4 from x-axis. But as coordinate, it is positive because it is above x-axis. So negative y coordinate, that is below x-axis. So C2 is below x-axis, check y coordinate is negative. Now just use those two formulae. X bar is equal to summation ai xi divided by summation ai, and y bar is equal to summation ai yi divided by summation ai. So just put values 5400 into minus 30 plus 4500 into minus 10, that, and so on. There are 4 areas, don't forget. Don't forget the negative sign. Just put the values in the bracket and get the answer. Total area is 15,908.3. Do these calculations yourself. Be sure that you can do these calculations without any problem. Calculation practice is also very important. So to find a centroid means to find xy coordinates of the centroid. Don't forget unit, and these are coordinates, so negative answer is possible. So if it is negative answer in your answer, you must use that negative sign because this is answer for x coordinate. So we have solved the problem. Now exactly using the same procedure, I have given you solved problems on centroid. Study those problems and study only those problems in which standard shapes are involved. Thank you.